All right, so today what we're looking at is using an integral to find the area between two curves. All right, and when we talk about this, there's a couple of things that we need to consider here. One is, what is the interval that we're dealing with? You know, where is that area between the curves? We also need to determine which function is on top. Which of them is greater within that interval, and then we're going to integrate the difference, okay? Now, you see here a formula that we'll be using, and it's this right here. It's the integral from a to b of f of x minus g of x dx. But I want to, at least visually here, show you guys where this is coming from, okay? If I were to, you'll notice here that f of x is this function here, okay, this parabola looking function, okay. G of x is this here, it looks kind of like a logarithmic function maybe. You'll notice that first of all, the interval that we're using from a to b lines up with the two points where these intersect, okay? So the interval that we're using is the interval between the intersection points, okay? Now, if I were to simply find the area, the integral of f of x, okay? If I were to find the integral of f of x, that would give me, let's make this a little bit smaller, okay? That would give me this area right here. Remember, the integral gives us the area under the curve to the x-axis, okay? Now, that includes the area that we want, but it also includes part of the area that we don't want. Okay? So, basically all we have to do at this point is get rid of the part we don't want. So that's why we have subtraction, and we have here the integral of g of x. Okay? Well, we can see g of x is, I'll outline this a little again so we can see it a little better. Okay, there's our g of x. And if I were to take the integral of that, I would have this area right here. Okay, the integral of g of x is actually the part that we don't want. Okay? So, by subtracting the integral of g of x, I'm taking away the part of the area that I don't want. That will leave me just the area between these two functions. Okay? So, that will give me the area that I am looking for. Does that make sense? Okay? I want you to know this formula, but I want you to understand the formula too, because it helps you remember it better as well. Okay, so you're going to find intersection points. Then, you're going to determine which function is on top. Then, you'll integrate the difference of the top minus the bottom. Okay, between those intersection points. So let's look at an example. One nice thing here is the fact that we do not need to worry about parts that go underneath the x-axis. Okay? So you don't have to worry about that negative area aspect coming into play here. Alright, so you'll notice here we want the area of the region enclosed by the line y equals x plus 2 and the parabola y equals x squared plus x minus 2. Alright? So the first thing that we would want to do is we would need to find the intersection of these two. Alright? Now, the diagram here actually labels it, but how would we find those? Set them equal to each other, yeah. X plus 2 equals x squared plus x minus 2. Alright, so we're finding the interval. Okay? So, of course, we solve this. We subtract x from both sides. So the x's are gone. We subtract 2 from both sides. So we get an x squared minus 4. So that means x equals what? Yeah, there we go. X is plus or minus 2. So you'll notice here, this is how they got this negative 2 here and the positive 2 right there. Okay? So now I know that I am going to integrate from negative 2 to positive 2. Okay?
In general, you always put the negative one on the bottom if you get two answers like that? Or you put the lower one?
Yeah, always set it up going left to right. Yeah. So now, which of our functions is on top? The line, x plus 2, alright? So we have x plus 2 minus the function on the bottom is x squared plus x minus 2. Do be careful to distribute the negative here. Okay? And we get, finally, the integral from negative 2 to 2 of a negative x squared plus 4.
dx.
Yep. And now we're back to doing the same stuff we've been doing. Okay? Take the integral, negative x cubed over 3 plus 4x. We're going to evaluate that from negative 2 to 2. And we'll get our answer, okay? So at positive 2, we get a negative 8 over 3 plus 8 minus, at negative 2, we get a positive 8 over 3 minus 8. And you'll notice we get a negative 16 thirds plus 16. So that's a negative 5 and 1/3, so we have 10 and 2/3. Okay?
Hang on, Alex.
Now, this is really what's happening, if you think about it, when you are finding the total area contained between the curve and the x-axis. Okay? Let's think about this for a second. The x-axis is a function, right? It's the function y equals 0. Alright? And remember we said you could take that part that goes below the x-axis and take the absolute value, or you could just subtract that. The reason why we can subtract that is because you're really doing 0 minus that function, okay? Now, let's actually see this kind of in action here. We want to find the intersection of our two functions that we're trying to find the area between. Okay? One of them is the x-axis, y equals 0. One of them is y equals x cubed plus 2x squared minus 3x. Okay? So to find our interval, and actually we're going to have intervals here, we are going to set the two functions equal to each other. X cubed plus 2x squared minus 3x equals 0. Okay? So we simply factor here. We have x times x plus 3 times x minus 1. 0, negative 3, and 1. So here's what we have. We're going to have two different intervals. If you get 3 intersection points, you're going to have two different intervals that you need to integrate over. Okay? It's important that you make this distinction here. Okay? So we have this, and if we put these in numerical order, it'll be -3 to 0 and then 0 to 1. Okay? I guess I didn't need to put the 0 twice, but you get the idea. We're going to do the integral from -3 to 0, and then we're going to take the integral from 0 to 1. Okay? And we're going to combine those. We're going to add those together here. Okay? Now, in the interval from -3 to 0, which function is on top?
The x cubed plus 2x squared minus 3x.
Yeah, x cubed plus 2x squared minus 3x. So you could think of it as this minus the 0. Okay? Between 0 and 1, the line y equals 0 is on top. Okay? So we could think of it as this. It's 0 minus the function x cubed plus 2x squared minus 3x. Okay?
Why 0 minus?
Well, because here's our function y equals 0. It's on top. You do the top minus the bottom.
Okay.
Okay?
Bless you.
So, at this point, we integrate both of these. X to the 4th over 4 plus 2x cubed over 3 minus 3x squared over 2. And there's a 0. We're going to evaluate that from -3 to 0. And then we're going to add to that. We have this negative, so it's a negative x to the 4th over 4 minus 2x cubed over 3 plus 3x squared over 2. And we're going to evaluate that from 0 to 1. Okay? So you'll notice here we have to do these two integrals separately, and then we're going to add the results together. Okay, so we're doing the fundamental theorem of calculus twice. Okay? Everyone with me here?
Yep.
Okay. So, let's just wrap this one up here by evaluating, and then I want to look at one more example, okay? When this first one equals 0, that's just 0, because all the numerators will be 0. So it's 0 minus, now let's see what we get when you have a -3. -3 to the 4th is 81, so 81 over 4. -3 cubed is a -27, so that's going to be a -54 over 3.
Which is 18.
Okay, that is 18, yeah. And then minus 3 times 3 squared, that's 27 over 2. Okay? So we have a -20 1/4 plus 18 plus 13.5. Okay? That's all the first part. Okay? And now we need to add to that this second part, okay? If I evaluate this at 1, I get a -1/4 minus 2/3 plus 3/2. So it's that minus 0, okay? This is one of those where when you evaluate at 0, it's 0, okay? So now we're adding to this a -1/4 minus 2/3 plus 1.5. Okay, and it's just arithmetic at this point. You got to put everything together properly. So -20.5 plus 15 plus 33. 33 minus 20.5 would be 12.5, minus 2/3 would be 11 5/6.
That's also what I got.
11.833333.
Yeah, you're right, I think.
Alright,
Where she's
we
right.
got it. Okay? Of course I am. You guys catch me all the time. So. Alright, so that's our area, our total area between the two functions. Okay? Okay, I know this one is in your IP anyways, but I wanna cover it anyways.
Let's do it.
Because here we actually have something other than just the line
Indeed.
that's equal, and you got to use some trig here. So I wanna do number 10. Okay, the illustrated curves are those of y equals sine of x and y equals sine of 2x. Which one is which?
The smaller one is 2x.
All right, good. The shorter one there is 2x. The wider one there is sine of x. Okay, so I'm going to label that before I forget. Okay, here's sine of 2x. Here's sine of x. All right, so that was the first part. Find algebraically the coordinates of A. What we need to do is find the coordinates of A. All right. And basically what we're doing here is we're trying to find the area between these two curves. Okay? And I know it shows us 0 and pi as intersections too, but as we're doing this, we should be able to find all three of them, okay? So how would we find algebraically the coordinates of A?
Set them equal to each other.
Set them equal to each other, okay? So we have sine of x equals sine of 2x. So how in the world are you going to solve that?
Divide by sine of x and you get 2 equals nothing.
No. Is there an identity? Yes, the double angle. Do you remember what it is for sine?
No.
You guys make me so proud. Alright.
707
Was it 1 minus
Cosine
cosine x
squared
sine
x.
x?
Oh, you're mixing both of them. You're mixing cosine of 2x and sine of 2x. It's just,
1 minus
it's 2 sine cosine. You had half of it. Just get rid of the 1 minus. Alright? So it's 2 sine x times cosine x.
How can that even be possible?
Don't ask. Just
There's a whole proof of it you could look up sometime, but. Okay.
something else.
Well, because we're changing the angle. We're changing the angle. So, alright, so guys, how would we solve this equation?
Divide by sine of x.
No, we lose roots that way.
Come on, guys. Divide by cosine, you get.
I would have not said that.
No, don't divide by functions because you lose answers.
Multiply.
Differentiate.
Do something.
Differentiate.
Zero.
Set them equal.
To 0.
They are equal to each other.
Oh, minus sine x.
Oh.
Why?
Still would not.
So why did I do this? Oh wait, Tyler, what?
Factor.
Factor.
Factor. There we go. Okay, now it's coming back.
That was actually the right.
Alright, it's been a little while. Alright, so sine of x, 2 cosine x, minus 1.
Oh my.
So now I know that either sine equals 0 or 2 cosine minus 1 equals 0, which means that cosine equals 1/2. Okay? And now we use our unit circle
No.
to figure out our answers, okay? Where does sine equal 0?
Wait, hold on.
Pi.
Pi over 2.
Pi.
No.
Pi.
0 pi.
90
At 0 and pi, good job. At 0 and pi, and again at 2 pi as well. Alright, if we kept drawing this,
I can get in the measure, I can't do that
Yeah.
fast though, so everyone else is talking. I
And then
can't get
3
it.
pi.
Okay, so here we have them. All right, we have these intersection points right here. Okay, all right, so we have those in a very ugly looking second period of sine of 2x. All right, but where is cosine of x 1/2?
Pi over 3.
At pi over 3,
Or 4 pi over 3.
and actually
2 pi over
one more quadrant over.
5
5 pi over 3, okay? So x equals pi over 3 and 5 pi over 3, okay? So right here is the 5 pi over 3, and right here is going to be the pi over 3, okay? So we found a bunch of intersection points. We actually did more than what part B asked us to do, okay? But I did this intentionally because I want you guys to know what you're doing on these. Even if you're not given the picture, okay? You're not going to be given the picture all the time on these, okay? So we found algebraically all the coordinates of the intersection points. So if we're finding the total area, okay, let's go with the total area here. Now it says from 0 to pi. Alright, so we're only doing, we can see it here, it's shaded in. But I don't need to worry about 2 pi and I don't need to worry about 5 pi over 3. But the reason why I'm looking at these is now I know what integrals I'm going to have to take.
Did
Yes.
we ever actually write down the coordinates today? Is it pi over 3 and 1?
It's pi over 3 and whatever sine of pi over 3 is.
3 pi over.
Not 3 pi, but root 3 over 2.
Oh, that makes way more sense.
Okay?
But it doesn't really matter, so now we take
Okay.
it into from 0 to pi over 3, pi over 3.
Okay, yes. And this is what we were headed for here. We want to take the integral from 0 to pi over 3, but then we need to add to it the integral from pi over 3 to pi. Okay? Now, the question at this point is simply, which one is on top? Okay? Now, obviously, we can look at the graph and we can see it, but let's say we didn't know which one was on top. We couldn't see it. All right? Just pick a number in the interval, plug it in, and see which one is higher. Okay? So let's say, pi over 6 is between 0 and pi over 3. Right? So what's the sine of pi over 6? 1/2. The sine of 2 times that, the sine of pi over 3
Root 3 over 2.
is root 3 over 2. Which of those is bigger? Root 3 over 2. So sine of 2x is going to be the larger one. So in this interval, I'm doing sine of 2x minus sine of x. Does that make sense to everybody?
Mm-hmm.
Okay? You're not always going to be given the picture to be able to just look and see which one's on top. You got to be able to, think it through and figure it out. Okay? Now, we could do the similar thing here. We have between pi over 3 and pi.
Pi over 4.
Okay? Pi over 4 wouldn't be in that range. That's in the other range.
4 pi
Um,
over 2 pi over 3.
how about 2 pi over 3? That would work. Okay, that's in there. What's the sine of 2 pi over 3?
Hold on.
Square root of negative.
Root 3,
One.
root 3 over 2.
Root 3 over 2. Okay? So sine of pi over 3 is root 3 over 2. The sine of 2 times that, so
4 pi over 3.
oh wait, that was 2 pi over 3. So sine of 4 pi over 3.
It's negative,
It's
so
negative,
therefore we're doing sine
Yeah,
x
that's a
minus
negative.
Sine 2x.
Okay, so good. We're doing sine of x first, because it's on top, minus the sine of 2x.
Yeah.
Alright, at this point guys, we're just integrating, okay? The key though is setting that up. So I'll let you guys finish that one off for your IP. But this is the kind of thing that you gotta work through. There's multiple steps here. But you just gotta think it through. Making a sketch would be really, really helpful. Okay? Even if you're not able to use your calculator, you should be able to make a rough sketch of sine and sine of 2x. Okay? And that'll help you see kind of where you're going with these. Okay? All right.